Okay, next we proceed to the shell side heat transfer coefficient. So for the shell side, it can be H naught or denoted by H naught, and the pressure drop as well. Okay, these are the general procedure. We may start with the calculated area or AS. So you require the tube pitch, the tube outside diameter, shell inside diameter, and baffle spacing. Use all the information from the general consideration that I explained previously. And then after that, we will proceed to the calculated shell side mass velocity. WS is the fluid flow rate that you can obtain from the balance. We have performed the balance initially, right? And then we have this area or the cross flow area to give us the mass velocity, or you can obtain the linear velocity from this mass velocity by having the information on the density. Okay, the density is based on the type of the fluid that you use in the shell. And we required, and next proceed to the calculate a shell side equivalent diameter or denotes by DE. So for this, you need to define what are the type of the pitch, whether square or triangular. So how can we decide the pitch? It also based on the process. So example, if we require higher maintenance or the cleaning process, so you may consider to choose the square pitch. Okay, next we proceed to the calculate shell side Reynolds number. We have the information on the mass velocity, the effective diameter, and also the viscosity. Or this information, such as viscosity and density, can be obtained from the table properties of the fluid of your process. And then calculate the shell side heat transfer or HS using this equation. So you have the information of KF here. So KF is the thermal conductivity that you may refer to the reference table on the properties of the fluid. And we have the NU, and you can obtain the HS, or otherwise you can use this equation to determine the NU. And then next to calculate the pressure drop using this equation. Okay, the value of JH and also JH you can obtain from this diagram or shell side heat transfer factor. So using this, you need to have the information on the Reynolds number and also buffer cut percentage. And then after that, you can obtain the value of heat transfer factor. This is to obtain the friction factor of GF.